Amidst an established backdrop of long-term warming, the expected impacts of climate change can vary widely in nature and extent across species, ecosystems, cultural sites, historic buildings, and park facilities. The National Park Service determined that understanding the relative degree to which park resources are susceptible to or unable to cope with the effects from climate change is important for responsibly managing parks in a warming world. These vulnerability assessments help the national parks identify when, where, why, and which resources may be most at risk, and which resources can most benefit from our direct management. Critical to our approach to climate change vulnerability assessments is the concept of sensitivity. A 1 degree change in temperature or 10-inch decline in annual precipitation may look very different in different ecosystems or natural histories. In the Midwest or New England, warmer winters may reduce the number of days of hard frost, increasing activity of forest pests and virulence of pathogens that can impact long-term canopy structure and composition in conifer or hardwood forests. Less precipitation and longer periods without precipitation can further stress species that are not adapted to tolerate periods of drought. Amidst temperature and moisture dieback, forests in cooler, wetter climates may be more prone to conversion to shrub or grasslands. Increased risk of disturbance like wildfire, even in places where these types of disturbances were historically less common, may also shift ecosystem composition. By contrast, similar changes in temperature or moisture experienced in the desert Southwest or Southern California may have a different outcome on native flora and fauna. For example, California already experiences intense whiplash between years and is prone to multi-year drought. In California's Mediterranean-type climate and places like the Mojave Desert, many rare species are drought-adapted, or annual species that respond advantageously to sporadic precipitation. Throughout much of the western United States, fire is already a part of this landscape. In historically warmer, drier climates, heat rather than cold may be a limiting factor for invasive species, pathogens, and insect pests. So rising temperatures may not present the same potential for ecosystem conversion or present different types of challenges. The sensitivity and, by contrast, resilience of a park to a changing climate is therefore ecosystem specific, but it is species and resource specific as well. Varying capacities of plants relative to animals to move in response to adverse conditions is an important consideration here. We can also imagine that abiotic aspects of the landscape, like cliffs and beaches, will also respond to weathering effects of sea level rise, changes in precipitation, or extreme weather in different ways as well. Additionally, we must contend with the often heightened sensitivity of our cultural resources. In some cases, these resources may be integrated within the landscape, or these resources are ephemeral in their nature. But often, cultural resources are static, and conserving the integrity of these resources does not allow preservationists to augment these resources without also dramatically altering the object, place, or structure. Conservation of cultural resources, as well as park assets like buildings, roads, and causeways, means knowing something about the building's material and construction, as well as the limits of these building technologies. Stone, stucco, or cedar shake, different materials may be better adapted to different climate conditions or different regions, or may simply be more historically accurate or just more available or affordable. These resources and assets are frequently interconnected with other resources and assets, such as state or municipal water, gas, and electric utilities. We have to consider how climate change will affect access to these services, such as electricity required for air conditioning during high heat events, or loss of some utility services during hurricanes or days of high fire risk. How might increasing storm intensity impact roads, power lines, and our trails? How will rising sea levels affect sewage treatment, or how will saltwater intrusion accelerate rust and spalling of concrete and metal piling structures? Arriving at suitable management goals and actions is a daunting task when we consider balancing the various exposure risks and sensitivities that intersect between myriad resources, assets, and values which parks seek to conserve. Here, the sensitivity reports that you will work to complete provide an important element in curating the necessary information as we move towards better management. To review, already, NPS's CCRP has completed Park Climate Futures. Through this seminar series, we now hope to unpack those futures and what those futures will mean for park resources, assets, and values. and as an output of this information, provide park stewards with information and tools for planning for climate change. The climate sensitivity reports you will create fit into the following framework. Again, we can conceptualize exposure and sensitivity as two sides of the same coin. Here, exposure, the character, magnitude, and rates of change experienced in parks, has been already described in the park-specific climate future reports. And your work will be to overview how those exposures may affect the resources, values, and assets in the region you'll be covering. Together, sensitivity and exposure offer us an idea of the potential impacts of climate change. Here we measure impacts as deviations from the historical baseline or trend, but understanding what this means in terms of a capacity to adapt and meet the challenges associated with climate change requires input from folks on the ground. That includes managers at the park level and subject matter experts who know the stewardship nuances and constraints. Together, potential impacts of climate change on a resource and the adaptive capacity, which is described by our subject matter experts and park managers, present for us overall vulnerability. In other words, how will the resource, value, or asset adversely respond to climate change, and what degree of management effort will be required to best conserve those resources, values, and/or assets. As climate change interacts with other stressors, such as land use change, pollution, and non-native species, ecosystems are changing beyond the bounds of historical variability and what we already understand about these systems. In this context, the resist, accept, direct, or RAD framework helps decision makers arrive at informed, purposeful, and strategic choices. In short, one can respond to the trajectory of change by resisting, working to maintain or restore based on historical or current ecosystem conditions, accepting, allowing an ecosystem to change without intervening, or directing, actively shaping ecosystem change toward some preferred new condition. Let's consider this framework through the analogy of piloting a boat. And we can imagine, as in this picture, a beautiful day, the sky is clear, the water is calm, and the wind is at our backs. Whether navigating a management solution or a waterway, the path is straightforward when there are few uncertainties and dangers, and when we have a clear view of where we're going. But what if the weather changes? What do we do when there are whitecaps, gale force winds, and the view is blurred by rain and dark clouds? As we sail into the storm, each option in the RAD framework offers its own costs, risks, and returns. To resist is to lower the sails and fight the prevailing wind using a motor to attempt to power through to our original intended destination. But this option may present high risk, high cost, and a diminished chance of success amidst the raging storm. To accept is to lower the sails and allow the boat to move with the wind, arriving wherever the storm leads us. But can we also accept this new direction and the hazards that come with the uncertainty of an unknowable outcome? Finally, to direct splits that difference. It's to use the wind, our sails or our rudder and our smarts to steer the boat to a new, specific, and preferred destination, both far from our home port, possibly far from our original intended destination, but also far from where the wind may have taken us and into that uncertainty. Of course, the path we chart will depend just as much on the conditions out on the water as the conditions of our boat. How seaworthy are we? Here again, vulnerability and resilience inform our capacity to make the best decision. The small, shallow keel of the historic fishing boats pictured at left at Chesapeake Bay Maritime Museum versus the Balaclutha, a tall-masted ship anchored at San Francisco's Maritime Museum, will weather storms in very different ways, will afford their own unique strengths and require distinct approaches in their handling. Of course, the path we chart will depend just as much on the conditions out on the water as the conditions of our boat. How seaworthy are we? Here again, vulnerability and resilience inform our capacity to make the best decision. The small, shallow keel of a historic fishing boat, Chesapeake Bay Maritime Museum, pictured left, as compared to the Balaclutha, a tall-masted, seagoing ship, San Francisco's Maritime Museum, will weather storms in very different ways and will afford unique strengths and require distinct approaches in their handling. In much the same way, we can imagine that different species, buildings, roads, ecosystems will each have more or less resilience and adaptive capacity. So understanding the sensitivities and vulnerabilities of what we aim to conserve becomes vital in utilization of the RAD framework. Whatever the future may hold, the choices we make in how we pilot our response to climate change is already defining how we will approach conservation in the 21st century. It's not always smooth sailing, but knowing where we want to go, how we want to get there, and what it'll take is important preparation for ensuring best outcomes. The RAD framework has become a vital tool in navigating this uncertainty, but using this tool requires important information about how climate is changing and how these changes will affect park resources. And that's where you come in.